So when Linux kernel basically want to search a particular address, and if he wants to find out like this address belongs to which VMA, so in that case basically your red black tree will be used, because searching an element through a red black trees and like it will be fast actually, because it will compare the address which it wants to search with the root node, and depending upon that address is basically greater than or uh, shorter than that root node, it can move to the left subtree or the right subtree. So searching of element through it red black tree will be easy for our Linux kernel, and it will be fast. Okay, but if you want to traverse through the VMAs, actually let's say you want to traverse from VMA 0 to VMA 1 and then VMA 1 to VMA 2, so in that case basically traversing will be easy by using the linked list. So this you are going to use for traversing, and this you are going to use for searching. Okay, and then mmap underscore cache basically, so Linux kernel has to maintain the how much is the memory basically allocated to this process actually. So it has to maintain the record, so it will basically contain the information like how much or the well, what is the last used memory area. So basically let's say if till here this memory is already allocated for a process, so it will store it will store this address, so till this address basically the memory is already allocated. And then free area cache, so this is the first address space hole, means the first address which first free address basically which we can use for further memory allocation, so it will store that address. Then you have pgd is basically page global directory, so this is basically the reference to the top level page table which Linux kernel will store the information about. So this page table pointer will be used to understand which are the page table basically which is maintaining this underscore structure. So if you remember right, so to maintain your virtual memory to physical memory translation, you have page tables, right? By using a page table you are going to translate the address from virtual to the physical address, right? So you have these page table, sorry. So Linux kernel use multi-level of page table. What does that mean? So instead of using a single page table, Linux kernel basically maintain multi-level of page table. So if you want to traverse or if you want to find some from virtual to physical address, first you will find the entry in the top page table. Okay, so from there you will going ahead in the second page table which you want to access, and then from there you have to go to the third page table, and this is the last page table which will actually give you the physical address of your memory. Okay, so this is multi-level page table system. Basically Linux kernel generally use two level of page table, so in that you will have this top directory, and then or three level, some if it is using three level then it will be a medium, and then this will be basically the last page table actually. Okay, so because these page table are maintaining or basically having the record of all the addresses given to this virtual address space, and these page table know how to translate the address belong to this particular virtual address space to the physical address space. So Linux kernel has to know which page table basically actually doing that, so it will keep record of the top page table, because when you have a reference to the top page table then you have reference to all of these page table will